Hi, in today's video we are going to be solving for the angle measures in the right triangle. Again, today you're going to need to have your calculator out. So if you don't have it out, make sure you get it out. Just like yesterday, we're going to start by just looking up how to set up to solve. So as I look at our first setup, we have our angle. This is our reference angle. That's what we're trying to solve for. The 35 is given to us. That is opposite the angle. Opposite the 90 is the 12, which is going to make this the hypotenuse. So I think about which trig function relates the opposite and the hypotenuse. That is going to be sine. Its sine of your angle is equal to the opposite side over the hypotenuse. So in this case, I don't know what my angle is. Its sine of my mystery angle x is equal to the opposite side of 35 over the hypotenuse of 12. And then we'll get on how to solve this in just a minute. We go to number 2. Here's my reference angle. 18 is opposite. 10 is adjacent. So I think about which trig function is opposite over adjacent. That is tangent. Its tangent of my angle is the opposite side over the adjacent side. In this case, the angle is unknown, x. The opposite side there is 18 over the adjacent side of 10. Our last one here is our reference angle. This side is next to, so it's adjacent. 32 is opposite that right angle, making it the hypotenuse. So the trig function that relates adjacent and hypotenuse is cosine. So it's cosine of x is equal to the adjacent side of 20 over the hypotenuse of 32. All right, so now that we know how to write the setup, let's look to see how we can solve it. For angles, we're going to round to the nearest degree. And just like we talked about yesterday, we want to make sure that our calculator is in degree mode. So take those calculators out if you don't have them out already. Now this is very different than what we talked about yesterday. To get to the angle, we can't just use sine, cosine, and tangent. We have to use inverse trig. We have to use inverse sine, inverse cosine, inverse tangent. So if you look at your buttons on your calculator where you had yesterday, there's sine, cosine, tangent. If you look above sine, there's sine to the negative first, there's cosine to the negative first, and there's tangent to the negative first. Those are the inverse functions we're talking about. So if I want to find the angle x is equal to the inverse cosine of that ratio. So I'm going to hit second cosine, and then 5 divided by 10. And I see in this case that my angle is going to be 60 degrees exactly. We go to our next setup. Its sine of x is equal to 20 over 30. To find the angle, anytime you're solving for the angle, you're going to use inverse trig. So this is the inverse of sine is equal to 20 over 30. So I'm not going to use sine, I'm going to use inverse. So second sine of 20 divided by 30. We hit enter, and we find that x is about 41.81. We're going to round to the nearest degree. So that 0.8 tells me that I'm going to round up. So x is going to be about 42 degrees. Our next one, number 6, we've got tangent of x is equal to 5 over 3. Again, we're solving for an angle. Anytime we're solving for the angle, we're using the inverse. So tangent to the negative first, the inverse of that ratio, 5/3. We go to second tangent, type in our ratio 5/3. We hit enter. And x is going to be about 59.036. Rounding, that 0.0 means that we're going to stay the same. So x is going to be about 59 degrees. All right, so make sure anytime you're solving for the sides, you use the regular sine, cosine, tangent. If we're solving for missing angle measures, we're going to use inverse sine, inverse cosine, and inverse tangent. So let's look at the next section. Putting it all together, we're going to write our equations and we're going to solve them. So for the first one, it doesn't matter which one we solve for first. So let's just pick x. If x is my reference angle, 5, the side I'm given, is opposite, 8 that I'm given is the hypotenuse. I think about the relationship between those pieces. Well, 5 is opposite hypotenuse, that's sine. Sine of our angle is the opposite side over the hypotenuse. In this case, the angle that we're looking for there is x. The opposite side is 5. The hypotenuse is 8. When I set up my equation, I see that what I'm missing is the angle measure. So x is equal to the inverse sine of 5 over 8. We plug that into our calculator, and we get that x is going to be about 39 degrees. Again, we make sure that our calculator is on degree mode. If you're not sure where we got that, but go back to the last section and see which buttons we hit. Now we want to solve for y. There are two ways to solve for y. If this is my reference angle, if I had started here, this would be my adjacent side. This would still be my hypotenuse, which means its cosine of y is equal to the adjacent side over the hypotenuse. Since we're solving for that angle measure, y is equal to the inverse cosine of 5 over 8. We plug that into our calculator, make sure that you hit second cosine so that you get that inverse notation. And we find that y is going to be about 51 degrees. Now, we could have also done, we know in a triangle, all three angles have to add up to 180, or if you remember from the other day, the two acute angles have to be complementary. So we could have just done 90 minus 39 and found 51 that way using our triangle sum theorem, or the fact that the acute angles are complementary to each other. All right, number 8 is our last one for our notes. We see that we have another one of these isosceles triangles. We're going to drop our altitude. We have to drop our altitude so that we get that right angle, because all the stuff that we're dealing with right now is right triangle trig. And if you remember that the altitude is going to split your base into two equal pieces, so that 30 is really two pieces of 15. Yesterday when we were solving for it, we were actually looking for that side, but now I have that side. If this is 42, then this is also 42. The key is to concentrate on one half of the triangle at a time. This is going to give us one right triangle. So when I look at these pieces, my angle right here is my reference angle y. 42 is my hypotenuse. 15 is the adjacent side. So I think about the trig function that relates adjacent and hypotenuse, and that is going to be our cosine. So cosine of y is equal to the adjacent side over the hypotenuse, 15 over 42. To solve for that missing angle, we have to use our inverse trig. So second cosine, 15 over 42. We find that y is going to be about 69 degrees. Now from there, we now know that this angle right here is 69, which is going to help us find that third angle. We can do the 180 minus 90 minus 69, or we can just do 90 minus 69. Either way, we're going to find that that angle measure is 21. Now, because it's isosceles, that altitude is splitting this angle into two equal angles. So that's 21. This is 21 as well. Or you could have done the whole process over again on the left-hand side. So our angle x is two angles of 21, giving us 42 degrees. Now, another way you could have done it is use that isosceles triangle theorem. If this is 69, this is 69, and then we could have taken 180 minus 69 and found that that whole thing right here was going to be 42 at once. So lots of different ways you can approach that problem to solve for your missing pieces. Remember, if you're solving for sides, you use regular cosine, sine, and tangent. If you're solving for angles, you have to use the inverse. So the inverse cosine, the inverse sine, the inverse tangent. All right, and that is it for today.